Hello and welcome to this. Welcome and thank you for your participation in this presentation. I'm Mahdi Shourabi, and in our team in high performance computing, AGL software and functions, we're working on different processors ranging from small microcontrollers to high performance SoCs. And in our ADAS ECU solution, we're working on AGL software to have it on our ECU solution. You will learn more about this product tomorrow at NetStalk. We will discuss more about this, and tomorrow I'm going to share with you some of our best practices that we use to manage AGL and other Yocto-based BSPs and how we can deal with them. So that will be interesting, especially for developers that dealing with this kind of problems. If you want to just start from scratch and tell the story when we want to build the AGL software, first we start, if you go through the documentation, you see that you need 4 steps. Just first you need to prepare your build host and then download the software and then initialize the environment, configure the build for your machine that you want to build, and then fire up Bitbake to have the artifacts, and then you can use it on your machine. But this is the very first step. If we want to have it for production, this is not suitable. Because for production we need to our builds be reproducible. So anything that happens, for example, for a car in the field or somewhere, you need to be able to maybe reproduce your software so that you can analyze the code or any bug fixes that will be prepared next. And after any change to your software and any feature you add, any bug fixes, you need to again build the whole software from scratch. So it's not reasonable to do it all again manually. And also there will be a lot of new features or bug fixes or security patches that come to upstream, and you need to follow them. And also one important thing is that currently the high-end automotive product ECUs, as we had in previous talks, they're going to have multiple cores, and with various vendors, and if you're using embedded Linux, you need to have a reusable infrastructure so that you can build for every machine that you're using in your products. So we need more than that. If we want to very fast go through the solution for this, we need to do it continuously. As the name implies, we need to be able to continuously integrate our new codes and software to make it ready for production. So if we want to prepare such kind of system, we need a minimum ingredients as an automation server. We need an automation server to program it to do the build steps that we want. And also we need a reusable build host. We need the build host to be consistent across all of our builds, because we don't want to have multiple products, multiple artifacts with different behavior. And of course we need some coding to program this build infrastructure. Of course, we need some repositories to maintain our code bases, and we need some safe place to maintain and to keep our produced artifacts. If we want to put it together with some open source solutions, we can figure something like this: that we need a build server, could be any well-known Linux distribution you can use for your builds. And inside it, we can use Docker system to prepare an environment for our builds and to be reusable. We can use Jenkins. The Jenkins server could be outside of this world, and use this build server just as an agent to fire up the builds inside this machine. And we have some local mirrors. We have some open source. From local mirrors, shared state cache that we can save it here inside this build server. and we fetch something from open source, and also we have some other local repositories that we maintain the CI configs or any other metadata that we develop above the, for example, AGL or any Yocto-based BSP. And maybe we have some customized applications that we can use it. So this would be the architecture of a continuous integration solution to build and to have these continuous builds. If you want to just think about, want to introduce some best practices that we can use. So for example, if you want to use Docker, you may see multiple possibilities for yourself. For example, you may use build a new Docker image for every of your builds. This means that most of the job should be done in the Docker file. You need to you need to run your build commands inside this Docker file, and after finishing building this image, so your build is finished. This has some side effects. For example, this may use excessive disk usage. Because for every Docker image, you're building the whole virtual Linux from scratch, so they have many common parts, and this may create some extra disk usage. And also, sharing these generated artifacts may not be that easy because, I don't know, maybe you need to mount some file system from host, and this is not easily accessible here. But the good point is that from a point of view of a BSP developer, you're dealing with shell commands, and that's much easier to understand, much easier to debug, and that's how it works. The other method is that building a new container for every build. This means that we have a general Docker image that suits for every for building every Yocto-based BSP. In this way, we need to do the job mainly in our Jenkins file, which means it means that inside your Jenkins file, you need to go inside the Docker image and sharing your files from host to the container. So yeah, it needs knowing some Jenkins file syntax. And it is a bit harder to debug because you need to do everything in Jenkins. And but the positive side is that you can have just one Docker image and create as many as you want Docker containers from it to start to have concurrent builds or multiple builds for different machines. And also the containers can be gone after any build. So when you get the artifacts that you want, you can remove the containers, and yeah, using these volumes, you can use Docker volumes to share easily files from inside the container after build to your host. So it seems better that we use this method too. If you want to check some more best practices. One good practice is that using predefined scripts, I mean shell scripts, and not directly run commands inside your Jenkins files. I mean, if you're using repo, you can have separate script for that and just call it inside the Jenkins file. One other practice would be good, that in notifying BSP developers that in case of any failure regarding the synchronization. One idea is that having nightly builds. So for example, every night you can get the most recent updates from Upstream and make sure that your build is compatible with the new changes. And if not, you can change your software for that. And yeah, one important thing is having fresh builds from scratch. That really important, because it shows that your build doesn't change. If you build upon each other, could make some problems. But a problem is here that these embedded Linux BSPs, Yocto BSPs, AGL software, these are going to be more and more complex, and we need a lot of features in DevOps domain, in CI side, and we have too many changes and needed features in BSP side. So how we can handle it? This is a problem that sometimes, especially for newcomers to AGL, when they want to use it for the first time and manage this in their teams could be a problem. If we want to continue this way, what would look like is something like this. We have a main repository, and when firing up a job in Jenkins to start a new build, everything will be fetched from Jenkins from this main repository to a work directory. All this is happening inside a container. Then we clone all the metadata and sources we want, and then we generate artifacts. Would be something like this. As I said, we go inside the container, and we have some build stages, and then we build everything. So if we continue with this method, what happens next is that if we want to reuse this build infrastructure for a new machine, for machine B, we need to again change everything in Jenkins file, and we need to create a new repository for machine B. What if there is a bug, and yeah, this is a real life experience that Bitbake may not accept this character in directory names. We need to again change the Jenkins file and do everything in all of the repositories for every machine that we have we want to build for. And what if a new CI feature needed? We need to notify, I don't know, in another way or to new audiences. So as you see, the workflow in this case is something like this. For any change for the BSP side and for CI side, we need to work on the same, the developers need to work on the same repository or change anything in the same Jenkins file. So this could be a bit hard. The problem that could arise is that, the BSP and CI developments are happening together in the same place. So this build system could not be easily reusable, and it's hard to add features. If we want to extend the CI part or BSP part, they can affect each other. And this is more error prone because when your builds when you get newer and newer builds, you need to harmonize all the repositories to make sure that they have the latest features you want. The idea is that how we can manage to isolate these two developments from each other. That means that we have a BSP world that is dealing only with Yocto project, with Bitbake, with meta layers, and so on. And we have a CI world that is just dealing with Jenkins, manifest, containers, and so on. This interface layer should isolate the developments and so that they can add features independently, and should be a common language for all the developers, all the professionals, all the specialists in software. To have this idea, the step one is that we can exclude all the CI actions from the main repository. So we have in our main repository, we keep our Jenkins file to just tell Jenkins that from where it starts and in which node it should use. And we exclude the CI part into another repository. And after firing up a new build, we use Git submodules to load this CI repository inside the work directory. Still, our BSP build commands are here. So again, we continue to build what we want, and then we save our artifacts that we need in our artifact repository. The next step would be also putting all these BSP commands, BSP scripts that into the main, keep it in main repository. So every time that we start a new build, we load the CI actions and CI features from another repository, and this CI repository knows that the BSP command that it should follow and it should do is inside this main repository. So then we continue to build what we want, Bitbake any images we want, and then save the artifacts. This means that we need two repositories. In the main repository, we have a tree like this. We have some build scripts that is some shell scripts that we defined to build the exact image and artifacts that we want. And we have some common build configs. We may have some assets that is needed during build. And we have a submodule pointing to the CI repository that has a complementary script to the Jenkins file. And if we continue this, in the Jenkins file, we can go inside the container as before, and then we load the complementary submodule that has the CI repository, and then we just simply load the complementary CI code and run a method inside it. And what is happening inside that method is we define all the stages that we need for the build, from initializing the build stages, from cloning metadata, and initializing configurations and building images, updating cache and SSH cache, and then we can archive the build artifacts. So, and as you see, these are the common steps for building every Yocto-based BSP. We can reuse it for any build. So the workflow in this method is we have an isolation between two worlds. Updating CI requires that developers in that side just push their changes to the CI repository and nothing to do with the main repository. And BSP developers are just dealing with the standard shell scripts, and every action they need to do, they need to just update those shell scripts. So anything regarding the BSP side, creating a new meta layer, building SDK, building a new image, different for AGL or other Yocto-based BSPs are happening in this side, and anything regarding the CI side are happening in the CI repository. So this architecture works for every Yocto-based BSP. It is easily reusable, easily extendable, and there is no mixture of expertise that CI developer that says, okay, I don't know about the BSP, or BSP says, I don't know about CI. And yeah, it reduces coding effort because the codes may not exceed 100 lines of code. And yet it is easier to debug because both sides can be independently debugged and checked without affecting each other. Yeah, if you have any questions, easy ones.
Very good presentation, by the way. Thank you. On a scale of like easy, average, or difficult, how was it in terms of the documentation that you needed to understand all this to get it up and running? Was it easy, average? Like, I mean like the Yocto documentation, the AGL documentation. Mm-hmm. What's your feedback on that?
I can say would be like medium, yeah.
Medium?
Yeah.
Okay.
Yeah.
So you had the documentation that you needed, more or less?
Yes.
Okay.
Yeah.
Okay. And how long did it take you to learn all this and get this process up and running?
Yeah, to be honest, I'm still a bit newcomer to AGL.
Okay.
Yeah, and it is.
I'm just trying to gauge, for a new person, a new member, how difficult it is for them to get up and running like you have. Mm-hmm. That's what I'm trying to gauge.
Yes. Yeah. If I want to give you time, would be like, I don't know, 2-3 months maybe.
Okay.
Yeah.
Okay. Yeah, that's very good feedback.
Yeah.
Okay.
Thank you.
And do you have some feedback for us in terms of what we need to improve?
Mm-hmm. Yes, I may have some ideas. Yeah, I can share. Yeah. Yeah.
You want to talk to this guy?
Okay.
If there's anything you think we need to improve, on the build,
okay.
Release process,
Yeah.
everything.
Okay. Great.
Yeah.
Okay, then if there's no question, thank you very much.